All right. So what about the transformation that the problems we have done last week? All three of them that you are familiar now? Have you went through in this actually weekend time? What about others? Yes, something want to hear about general pivot point rotation, fixed point scaling, and general scaling direction. We have said in the general scaling direction that it's not uh, necessary to work on the graph because without any object, the scaling is actually quite difficult to understand. And for that problem, the graph is more complex actually, so that rather than maybe the first two, that you need to have a graph activity. The third one, that is scaling direction, that actually you have seen in the slide only that a problem has been given, whereas just let me share. You only need to work on actually that if it is in with formula, as we know that positive rotation, then negative rotation, then scaling, then the negative rotation actually happens. So that you just only put the values in there for with using formula and do a calculation, you get the point, the transform point. Whereas without using formula, that time actually do step by step. That you do the positive rotation, you can see that rotation matrix. Then whatever the point you get, that point will be scaled with that scaling matrix, that one. And then the point you get, that point will be the negative rotation actually, then you get actually your desired point. So you may either actually put only the point on the graph, that would be more simple. You can see the change of the point location, that's all. But you will not actually find out that the degree of rotations actually, especially with the size has been expanded, as you can 2 and 3 the scaling factor, so definitely the size will be expanded. That you will not find out actually unless you have a object. So that we said, maybe at least if you know that how to do in actually with using or without using the formula, that would be okay. And for but the other two, general fixed point scaling, that actually we have done a solution, and general pivot point rotation, that you need to do with using formula, without using formula with the graphs. Okay, that is must. And I requested you because it is necessary actually you get prepared for the exam from now on. I already mentioned that there is a chance of having unique problems to solve during the exam time. So that will not work out if you have any other master plan. Okay, so better you should be careful. Otherwise, it will be difficult then. Okay, this is maybe the last topic that we are going to do. I want to actually maybe the last class I don't want to go through any new topics for that. Maybe we have some discussion or something. And this one, maybe we'll do it within these 2 days, the classes, because we are approaching for the last week of the classes now. So that's actually called the graphics pipeline, a very important concept for anywhere that whenever you will actually go for advanced graphics study, you will find the rendering technique or the pipelining technique for the graphics to generate the image. Okay. Before going in that, anyone have any question regarding your content, syllabus, or preparation, or anything else? Anyone have any question or anything?
No, sir.
No. So are you worried about any exam?
Without this one, sir, I didn't get your question.
Not without this one. I said like about this course, definitely. About the exam, like Viva exam or written exam. Do you have any kind of any concern
Sir,
that
problem is I couldn't finish the syllabus yet. That's why no question is coming.
it has no relationship? Consider it is actually done.
Yes, sir. All topics was understandable. Just need to go through those all.
Yeah, I want to hear from others as well, actually, because this kind of scenario is not actually you can be representative, right, Ashik? So maybe what actually other student situation, what actually they are
Yes, sir.
thinking about, that's actually the concern.
Yes, sir. We're
Uh,
going through the syllabus, sir. We have started revising from the beginning. So
okay.
after going through at a certain point, if we face any kind of problem, then we'll tell, sir. But
Did you
I
did
think
you go through this transformation, Uday?
no, sir. I haven't gone through, sir.
Why not? Because this is why actually I am taking some time to stressing this on, because whenever we are doing, if you go through that, at least solve one problem, then actually two things will happen. If you have still some confusion, you can actually discuss during the classes. If you already can do, then your confidence is high and that is done, you know that that is done. I'm stressing because this transformation will affect your entire written exam. It has a good part actually, right? As it is one
Yes,
and a
sir.
half hour exam in the written, you can understand that this is actually not too many question you can have, right? So if you don't have too many question, but it has actually possibility to have three problems here, right? Maybe not all three will come, or maybe you never know. So this is actually the right time actually that you take the preparation. Not previous thing you take preparation, no problem, but better actually you take the preparation from here as well. That is actually my concern. And syllabus, this is actually the graphics pipeline. There were another topic, but I'll not go for that maybe, because I could not assess the time actually for 1.5 hour exam. I could not actually assess that many things, and I'm not intentionally extending your syllabus. So that topic you will have in your exam, at least something. And also I have a wish actually, maybe last days of this class, also maybe you can discuss about your final structure of your written exam. So if you want to take the preparation on that time, would be difficult, okay, unless you actually be familiar with this method. Like most of the problem, we can easily change the value for unique value for the unique student, so that actually you could be a little bit in trouble if you are not able to solve the problem. That is actually my concern. Okay, so let us start with this pipelining, that is actually called graphics pipeline. We already said pipelining or rendering pipelining, that is actually called, is a technique for sequentially that actually image generation that actually we do. Now, as you know that how actually painter actually draw an image. Commonly, some scenario if we want to take for any conventional painter, uh, they need some model when actually they try to actually draw something. You may say like, so not every cases that you need model. Maybe I am not sure that out of this all of you that anyone could be painter, you might have, even you have actually a model, or model is actually something that you do imagine even if you don't have something physically, so that into your brain there is something comes, then only your hand actually try to draw on the basis of it. Whenever you draw for every cases, you see that they try to make actually the outline or maybe some object, right? And then actually they try to do it with maybe if it is related with color, if it is maybe actually that is sketching with only the pencil, they try to go through and more actually advanced work one after another. So if everything done sequentially, okay, it not actually instantly it's possible, to draw, as like maybe even if it is go for actually a computer based draw, that is also actually done by sequential programming from that outline 2 up to that, actually giving the final shade about the lighting, reflection, color, actually that portion of the color. So this entire activity is actually called the pipelining technique or the rendering technique. Okay, rendering is a actually word commonly used in the graphics. So this actually sequential processes has individual processes or steps one after another, and they also divided into some stages. Okay, so maybe few of the steps are coming in one of the actually stage. Okay, now, especially when rendering in real time, different hardware resources are assigned for each stage. So in computer, actually generating that image, a big part is actually grabbed by the hardware. Okay, so in software, whenever whatever you do, that whenever it goes for actually execute, then hardware has a very big deal for graphics display. Rendering is a process, we come in the formal definition now, is generating an image from 2D or a 3D model, okay, or models in what collectively could be called a scene file, a terminology, okay. So a scene file is actually something, whatever you are going to actually generate, it is actually based on that. So that whatever you are imagining, say like you are imagining about a scenario, okay, a scenario of maybe a village actually view, a natural view, maybe that is all actually a scene file. Now, or maybe a model that you put someone, actually you are trying to draw a portrait, okay, so that actually that model is becoming the scene file. So that is actually collectively it's called actually the scene file by means of computer programs. Okay? Also, the results of such a model can be called rendering. So whatever actually you are generating at the end, that is actually through the rendering process. Okay, a scene file is contains objects in a strictly defined language or data structure. So you can understand that a scene file or maybe on any image, we already can go back in that chapter that we have discussed that it contain many actually objects, right? They have the geometry, they have actually the interaction. So that is actually the data structure for that image. Okay, so that how they are having a relationship one to another. Okay, that thing you need to know, then only you can actually put that in a logic to generate in your image. Okay, so it would contain the geometry, the viewpoint, the texture, lighting, shading information, and as a description of the virtual scene. So you can understand that an image actually not simply an image, it has actually many things that you need to understand. It has some many things to have some numerical values that actually you apply into your program so that actually the image can be actually created. We'll go through most of these actually topics, what actually are they, about what actually we do understand that these are actually very important point for an image. The data contained in the scene file then passed to the rendering program to be processed and output to a digital image or raster graphics image file. So you can understand when you were drawing the flag, what actually you have done. You actually had a scene file in your mind, then actually you actually drawn that one in a paper, maybe to identify the specific points. Then later, actually, you pass that in a program. Okay, so those point values you have passed in that program so that you can in the display you can see that actually your flag has been created, right? So rendering technique is the process. You can see that from any model that you are actually generating the image. The very simple example here that you can see in rendering techniques, three-dimensional actual perception here. As you can see that we already always say it's three-dimension is actually kind of an illusion because our everything is we are understanding as like two-dimension. The depth what actually our brain can understand, that actually gives us the idea of three dimension. Okay, so this is actually the object you can see at the very beginning, an outline form. then maybe use the basic color, then use the lighting, the first case of lighting, that is. Then we go for texture mapping, what actually the content, every content have actually on their body. Okay, so two-dimensional textures are actually wrapping around the three-dimensional objects. And finally, maybe we are doing the shading of reflection and all these things for the lighting. So you see, from every step one by one is actually whatever you have completing, the output of this one is actually becoming the input of this one, and then output of this one is becoming the input of this one. This is the way actually the process one by one it is going on. So that's actually that rendering technique. Okay, and the scene file could be it looks like that some of the model that in some place of the corner that you have those objects, really you have those objects, so you are actually watching it and actually drawing it. If you don't have whatever you have in your mind, that is actually that in the scene file that you are having the imagination. So 3D computer graphics or pipeline, graphics pipeline refers to the sequence of steps used to create the 2D representation, 3D scene, the same thing. And once a 3D model has been created, for instance, in a video game or any other 3D computer animation, the graphics pipeline is the process of turning the 3D model into what the computer actually display. So you see, if we consider that actually whatever we are drawing, that is actually a two-dimensional actually space. Whatever actually in the scene file that actually seeing, they are mostly in the three-dimensional space, isn't it? So our that conversion, maybe we are doing that the conversion whatever it's look like in the two dimension. The nature of the processing steps to display computer graphic and the order in which they must occur. So this is actually the rendering process in different way. It has been actually explaining the main understanding about the rendering process is this one, or the pipelining process. So you only need to understand that from the very actually primary level, that is actually you can see here that outline based or the primitive based, that we are actually applying sequentially one after another this different process to get actually our desired output or the image. That is actually the rendering process. Primitives are processed in a series of stages. Okay, each stage forwards its result on the next stage. Okay, pipeline can be drawn and implemented in different ways, and some stages may be in hardware, others in software, like this way. And two-way viewing of the pipeline, transformation perspective, operation perspective, that we will see that what actually in the pipeline in basic terminology, that what actually one after another we can understand, and these terminologies are very important. Means this is maybe someone go for advanced graphics study, then this part could be one chapter actually that you can work, or maybe the graphics software that it works, it actually has those the specific software for individual of these processes or tasks. Like the first one is a modeling transformation. Now, what is actually the modeling and model that we already have seen a 2D or three-dimensional, especially that object that we are considering model. We see that the important actually actor, right? That the content in the scene, that is actually the model. Now, every model defines in their own coordinate system, that is called the object space, and then modeling transformation orient the models within a common coordinate space, that is actually in the world space. Okay, we'll see that what actually the example is. You can see here that whenever we think about this is actually the model, a modeling transformation. As you can see, that individual model now belongs to a scene. Okay, belongs to an image that were actually they do. Now, whenever you create individual model, that object that has their own coordinate. Now, I'm taking that one into world space. Now, this is actually the world space, because this object is now actually putting in one of the specific location of that space. So it has actually XY coordinate, and according to that it has a location. Okay, but it also itself as well, it might have its own coordinate system. Okay, so in that X and Y. So this is actually called the modeling transformation. You create the model and you transform that in the actually uh, in the world space where actually the object should be put. Okay, then we have the lighting. Okay, lighting is actually comes little bit late because that actually it comes in different phases, and also actually when you take this one, this is actually you understand that we are only creating the model, and for the image that we are taking that one as just like for the outline. Okay, now the vertices that lead shaded according to material surface properties. So still you are actually working onto the graph now. Okay, so that in the coordinate base actually you are thinking, because you can see that we are talking about coordinate system. So that's why we are calling vertex, okay, or the vertex. That according to the material, that what kind of material actually are they, and surface properties. You see that light has a relationship regarding that. So if it is wood, if it is metal, if it is actually some kind of plastic or maybe glass or maybe transparent object, definitely that your lighting will be different. Okay, there are some different model for it. We'll see what are the flat ambient fog with some example we'll see later. Then the viewing transformation. Now in your image you actually created that objects that in a scene that you have put down. Then actually you are thinking about that vertices, about the lighting. But rather than most important is actually that in world space, how actually and where from actually you are looking at. Okay, that is actually the viewing transformation. So viewing position is actually first you have in the middle. Okay, so that it transform to the origin, and viewing direction is oriented along the z-axis. So according to that one, we draw that will be, so like I have created an object. Okay, so like two model I have. We said about in modeling transformation. Okay. So what actually we are thinking, they have their own coordinate system. Okay, now we are actually taking that, transforming that in actually the world space. Now in world space, say like my this object is here, this object is here in their random location, and that can be actually called as a world space. Okay, in that world space or the scene that we have done the modeling transformation, then we are thinking about the vertices and what is the relationship with the lighting of them. Okay, then we think about that viewing transformation that we have said. Now viewing transformation is actually that according our we can say like our camera or maybe eye. These are actually two options that actually we can view. Now you can see that whenever we are thinking, then we are thinking about that the z-axis, right? This is maybe my x-axis that we understand. This is maybe the y-axis. This is maybe the z-axis. So you definitely what whenever we see the image, definitely we look at the in the middle, right? Now in the middle means the image, and actually you also have a gap, and that gap is actually the depth of for the z-axis. So viewing transformation is actually your position. Now you can see that if you just move your position from here to here, okay, uh, then definitely it changes. So viewing transformation is something whenever you actually change your viewpoint. Okay, so whenever actually you change your viewpoint, so now you can see that definitely the image will be look a little bit different. So this viewpoint actually is very important, that how do you look at, which position from you look at. Okay, so on the basis of that the image will be changed. Now next is actually that uh, projection transformation that we describe in here, then maybe we are coming back. Is a projection, that transformation. The projection whenever we are seeing, then you can see that we need to actually create the view volume. What do you mean by view volume? Because you see that the objects maybe you created in the model, that time you take in the modeling transformation, the object sizes are all actually whatever the size that you have actually created, that size is over there. So that means actually you created a box which is 2" by 2" in a square shape. So that box, or maybe 2" in the z-axis as well, if it is a box, that could be a actually three-dimensional. So whenever you take that in the scene file, so all the boxes are same size. But the whenever you go for projection transformation, now you are creating a volume on your that image. That means actually some boxes may be in the behind, some boxes are in the front. So whatever the front, definitely that will you will see little bit bigger. Whatever is actually behind will be little bit smaller. Now you are changing that actually that one. Now that is actually the projection transformation with the perspective projection. Okay, this is actually they given you the perspective projection. But if all the sizes are same still in that, that is actually called the orthogonal projection. So you can see that we at first think about the object to take that in the space, we think about the lighting, but most important one is actually think about the camera now, that from where actually, or eye, that actually from where we are looking at. Then we are thinking about the scene, what inside the objects you have, and how you are looking at or projecting on those objects. So we need to actually think about the either perspective or orthogonal projection. And then we think about the clipping. If you need to actually for whenever you are do that projection, then some of the object you cannot see, some of the object you will be having like from the side, that it will be actually cropped or maybe clipped. Okay, clip is actually that cropping that the volume. You do it like with some of the software that most of the actually image related software or picture related software, you see that there is option for the clipping or cropping that actually you do. Then you, it is important, now you take your image to actually in the display to show. Okay, now it's coming about the devices. Now that is actually called the viewport. Yeah, the device in actually terminology they call actually the viewport. So you actually take that one to show that in a actually image. Now you need the depth as well, the screen also actually you are showing on that. So that time you go for actually main activity for the rasterization. Your entire discussion of that coordinate system now will be transferred into the pixel based system, because most of the devices are rasterized, so that we think about the rasterization. So rasterizes the objects into the pixel, interpolate the values as we go. And then actually there are many things you need to do, the advanced work for the graphics image, like thinking about the color, the depth, again the shading. Okay, changing in the color, the combination of the color, maybe other image combination and so on. So these are actually the activity for that the pipelining process. Okay. Okay, sorry that so if we just whatever we discussed here about the pipelining process in quickly, if I just go back to the drawing board here. So this is up to that we discussed in that what is called that viewing transformation, right? That at first we have seen this one is actually our model that we have created, and that is actually modeling transformation, that MT. Let's see. Then we had lighting for the objects from their own coordinate now comes in the world space on that coordinate system. Then we are thinking about the camera or maybe the eye, and that is actually we are calling the viewing transformation. Okay, and from that viewing transformation that we have later we said the projection transformation. Now this is interesting, we said that with the view that actually we are seeing, that need to have a actually volume, right? Whenever it's a volume, you see that it's talking about the depth. And you can see that now this is actually with any image actually we have that actually kind of volume. And you can see here that volume is actually what you see now. Object is having some depth, and our this is called the projection transformation. Okay, so we call it actually the projection transformation. Projection is actually that our viewpoint. This is called the viewpoint. This is called the viewport. Okay, so that from our viewpoint, that we are actually looking at the scene for the every object. That object, how actually we can see it has a projection. Projection means what? The light has to be fall on there and then reflected onto your eye. On the basis of that, actually you can do your projection or projecting on the objects. That projection can be done in two types. Okay, two ways that actually we can think that the volume, that three-dimensional depth has been created, can be like you can see that it can be like this way. As I'm not very good in drawing, but you can imagine like our viewing, that range is actually get wider, isn't it? You have seen that the uh, what is called the far distance, that actually whenever you look at your that viewing angle, they started to get wider, isn't it? That's why you can see many things from the far distance, right? That's actually a common scenario. So this is actually our real life scenario. That is actually called the perspective projection. Okay, so I'm just writing the short notes, it was very difficult to write. So this is perspective projection. Perspective is actually what actually we feel according to our image processing done in our brain. Okay, so that's actually perspective. But what actually we are doing in the computer, that means through our program and so on. So definitely they will not be done according what actually our brain already is doing for viewing the image. You have to actually generate the image according to that, like in the animation whenever they do it. So it has to be as like in the real life. That's why this is actually depend, this volume is depend about the perspective projection. And this is actually what I have drawn in here. This is actually the orthogonal projection. In the orthogonal projection, the objects in far and near distance, whatever you have, they are actually same size. And I told you, like the model they create, especially that the IUBAT building that model in the ground floor with that glass, that you see that through that glass they have created actually a orthogonal model. Okay, so they are actually, the objects are everywhere is actually same size. But whenever you create a perspective projection, this is actually the orthogonal projection, that O and P. You see that one of the function that you use in your initializing the screen, that orthogonal function, right? That orthogonal function actually gives you what? You see that you take the value for what should be in my right side, left side, up and down, and near and far. And another actually that two concept, near and far. This is actually called the near screen. This is actually, or near clip. This is called the far clip or far screen. Okay, so this is actually the near screen you can see, and the far screen. You see these two actually has actually the differences. Okay, so an object which is actually that size, a triangle, maybe is showing in here smaller. Okay, and whatever actually you can see here in the triangle in here, and that far screen is actually having the same size. Okay, that does not actually change because according to the projection it gets actually the enlarge. So this is actually called the projection, that transformation that is done a relationship with your object and also your viewpoint that actually you have done. So everything has a sequential step, as you can see. Then next actually we have seen that is after projection we have that clipping. We said in the clipping is something which is, where is that screen gone? uh, that is actually whenever you have a viewing volume and you change your viewpoint, you can see some of the object you maybe cannot see from the corner, or maybe that from the other corner. So you need to clip it according to your actually the viewing space that you have. Okay, and so you, what you need to do, if it is necessary, you need to crop or clip the objects. Okay, You can remember whatever the point I'm actually discussing here, they are not the all. There are many other actually in between points are there. So it's actually a very vast thing. Just the processes that actually main processes that actually we are talking about. And then whenever my image is actually ready for most of that degree of the angles that actually we have created, then that has been transferred to a device. Okay, and whenever we are actually transferring to a device, so like this is my device in the computer, and then the device is actually called the viewport, and definitely the device how it will be related, like you see that the image that you have created, this is one type of device. If you go for maybe a mobile version, you can see that there could be another different type of devices. So according to the viewport, that it has to be changed, like your width or sorry, your height and length of the screen, especially that you have some aspect ratio. There actually the relationship comes with the aspect ratio. So that viewport function has actually the aspect ratio values for it. Now, and in here, we know that that is actually the raster graphic system. So all of your image in the from the vertex relationship has to be actually transferred to that in the raster form, like in the pixel base now. And that's actually called the rasterization stage, right? Do you understand the processes, the basic processes?
Yes, sir. Got it.
Yes. Okay. So you see that every of those actually steps, these steps are actually a single chapter for computer graphics to understand, because every chapter, every of those discussion, they have a many different logic. They have a different algorithm. They have many mathematical, geometrical interpretation, so that you can use actually your software that actually to work on. And these are actually the fundamental for working for the image processing that you go. If you go for the computer vision, object vision, and all kind of advanced work, these are actually the fundamental that we understand. So I hope that in at some point, if you go for your higher studies for any graphics related, image related that study, then you will find these are actually there's some relationship of these topics. Okay, so understanding this activity is actually important. Whatever it comes in the exam or not doesn't matter. Okay, but understanding these things are actually important. Can you see the slide? I don't think so, right?
No, sir, we can't see it.
Oh, okay. All right. So this is about that pipelining as a process as a whole. Then we will discuss about some of the stages. You see that these are actually we have discussed about the processes, the pipelining processes. Now these processes can be done in different stages, three different stages. They can be actually defined like application stage, geometry stage, and then the rasterization stage. You have seen that this is actually the rasterization, that process. They have many other work to follow. Okay, so that is actually another stage where actually many things can be done. They have been actually defined in here. The first application stage, maybe you are giving an input in the computer to creating the image. That's actually the application stage. Then you go for that all the instruction has been taken and actually it is working into the machine, and that's actually the geometrical stage. And finally it's showing on the screen. That is actually the rasterization stage in generally to understand. Okay, so that's why we will check that one. This what is called, that is actually the magenta color, or that is sky blue, consider that one, is indicating this is actually the software based actually activity, where the later all the activities are based on actually the hardware based. Okay, so we will see that how these three stages are actually related. The pipelining process in general to discuss, as you can see that you have the vertices. From that vertices coordinate system, from there actually that you created the primitives, then actually you take that in the rasterization form, that means the pixel based. Then you use the color for the pixels, you do shading, testing, mixing, and so on to show that on the computer in the frame buffer. Okay, so any object that you want to create, you take actually the vertices. Everything is actually created with the vertex, as you can see. So coordinate system, so vertices that you can see that from there you taken the triangle. So many number of those primitives, that geometrical primitives can create or a shape, as you can see here. That triangle in screen space, when you take in the screen, you must have to take it for the rasterization base. You can see that rasterization means those pixel based as it is going. Then you are actually working with fragments with the color, those pixels, okay, the raster operation that we are calling. And then actually we are processing that into our viewport to show that in the device. Okay, so this activity started with actually to showing in the screen. As you can see, remember the video controller, right? One of the component in our architecture, that video controller get the signal finally about actually this one, so that actually they can process on the display monitor. Okay, this is the pipelining process, just for through some diagram that has been explaining. Like in the application stage, you write program to create those objects, then take those objects for the geometry stage. They try to, in the geometry stage is actually three-dimensional triangle that you can see to two-dimensional triangle, as you can see, right? And for it actually, the two-dimensional triangle, you do that 3D position to the screen position, because you are thinking about the screen now. Whenever you're thinking about the screen, that is going for actually now with the triangle with many number of pixel. And then you use the color, and from that color you use the shade. As you can see that shade is related with the lighting. So finally what actually you get, like three-dimensional that object to two-dimensional object, from two-dimensional object to the pixel based, finally into our system that we want to show. Application stage, there's three stages: application stage, geometry stage, rasterization stage. Application stage is actually working based on the software, and in several CPU that actually you are creating. Maybe mostly you read the world geometry database and give the user input. You can see here the example here, that what actually you are doing in the application stage. Those data is now creating a shape, right? So that's why it says read the world geometry database and the user's input. In application stage is driven by the application, where it begins the merge generation process that results in the final scene of frame of animation. Okay, so usually you get actually the geometric primitive in 3 dimension. Okay, like polygons or mesh, that multiple number of those small primitives create actually kind of a shape. Those are actually, or we can say in the model that actually we are going to create, right? That model. Now our then first process come in the modeling transformation, so that we take the individual model to create, done by the software. They are reading data, the world geometry database. You may give the input through your mice, trackball, tracker, sensing, gloves, and so on. That through that actually you are creating the data, that values for actually creating the object. So through the user's input, that whenever you give that application stage, the change the view are seen. Now the application stage, from there we go in the geometrical stage. Geometrical stage called geometry engine, and they call it, like that is mostly about that hardware based, that actually it is done. So that in the geometry stage, from the application stage you get the model. In geometry stage they started to think about the image file or scene, that where actually my model will be transformed, so that that modeling transformation that actually it comes. So it actually gives you the two-dimensional geometric primitives, or 2D politics polygons, that's for two-dimensional. Like the modeling, you create the shapes in geometry space uh, from the program that actually comes from the application, that stage. Okay, so you get the model that as like shape, then you transform that one, modeling transformation. Then you check the viewing transformation, you check the hidden surface elimination, that is actually concern about the viewing that changes, the viewpoint changes. And then actually you have some shading, that reflection and lighting, especially that one, and then you pass that object for the rasterization phase. That is actually goes for the rasterization stage, the next stage for. So you see that the input for this stage was actually that codes that actually created through the softwares or creating for the objects. Then you take that as actually that output for the application stage is input for actually the geometry stage. Then actually you do work on it, and finally whatever actually the image now looks like, that has been you are passing for pixel based definition. So entire of this definition are related with the coordinate base, right? So if we just individual, then in the rasterization stage, there are actually some more activities done, like sampling they do. Why sampling? That we will see later, that what actually it is. Then the texture mapping, that what actually the texture on the body of the object it will have. Then composition, if you need, then you need to do the composition, or the quantization of the color or intensity up and down, that the values that you do, and finally you get ready for your that image to display on the screen. Okay, so you see that all are actually sequentially done, and there are many advanced work. These are also actually many advanced work they do for many software that take the help for working for it. So the three stages, again, the application stage, the geometry stage, and then that rasterization stage. So you've seen that this is actually, you pass your code or input, that whatever it is actually you have, you give all of them, then actually the object creates. You take those objects, you change all the actually activity that actually you have for changing the viewpoint and all these things, and then actually finally you take give it for pixel based definition, and the pixel based definition to they get the signal for the video controller to show it on the screen. Okay, so you see that this part definitely is actually very important for the hardware based, what actually hardware setup the machine you have. On the base of that, actually you can see the image on your screen. So this is an example in more actually easily you can understand now. This is actually what a scene file. Scene file what? Okay, we are going to generate an image which will look like this one. Now, we say the scene file has actually the in detail of the object's data structure. What could be the data structure? Data structure, these objects are actually considering having individually many data. Okay, like that every pixel that if we are not thinking about the pixel at this moment, but at the end of the day we'll go for actually understanding. So every pixel containing the different color will be coming from actually that every object's creation that actually you do create. So different shape of the objects, different primitives you have actually used to generate for that actually image. The relationship with the light, you see the complex light relationship, that part on the wall is actually brighting. They don't have different color, they will be entire same color, but whenever you apply that shading, that reflection, then actually the thing will be changed. You can see here there's a reflection portion of that wall that actually you have. So whenever you need to draw, so you can see that it is how complex. So that maybe some part of that location of that wall should be defined with a different actually data structure for the image in here. And this scene file, we start from actually the very what is called that starting point. We consider that has been actually done some coding behind it. You created the model. Now the model and shape that we will see in their own coordinate, we already said this is actually the own coordinate for designed by polygons, parametric curve, surface, implicit surface, the internal surface, that means. And like these are actually internal those surfaces, because on the basis of it, that the shape, size and object for the primitives also actually change, defined in its own coordinate system. That is actually the thing. Now we are taking that one for the modeling transformation, so that objects put into the scene by applying that translation, scaling, rotation. You see that actually we have done in the last chapter with the transformation chapter here. So why it is so important? So you create your model in your animated that image, that page what you are creating, you apply then different function on those models, and they will go in different position according to that, and also have some movement if you want to actually do it. Now, linear transformation or the homogeneous transformation is used, and we are actually not considering any perspective of view here. Okay, so this object looks like that. You need 5 of them. They are same size in the 5 different location they have, right? That is actually the linear transformation. Homogeneous transformation we do. Now, the location of all the vertices are updated by this transformation, so that this location in the space, for that actually, whatever we had in their own coordinate system now will be changed, and you will actually change it according to your image what it is required. Okay, so this is the modeling transformation. Coming to the world space, this is the projection, that projection transformation. Now this is we one of the type that actually we have already we are considering here in this image, which is actually the perspective projection. So that what actually we can see according to the volume, we can see here, this is actually the perspective projection, the volume that actually we create, and the object according to its actually near and far, that we actually how it will be look like that we do, and from the viewpoint it is getting wider as long as it goes. Now the difference with the orthogonal, you can see they are actually always same, that you are actually the view that what is called that angle that we are creating for, they are actually the parallel projection as well it called. You see that this is actually the parallel, that all the lines, but from that actually the angle is smaller to it is actually the wider as far as it goes. Now we are actually thinking about this perspective projection. So how actually want to create a picture of the scene viewed from the camera, we apply a perspective transformation to convert the 3D coordinates to 2D coordinates of the screen, and objects far away appear smaller, closer objects appear actually bigger according to the distance we know it that should be. Now that is actually, you see now how it looks like. So actually, the scene file, if you go back to the scene file, that now you can see that after the viewing angle, or maybe something like maybe in the z-axis that we are seeing, and it is in the origin, our viewing angle is in maybe the origin point. So that's the origin. Why? Because this x and y coordinate the origin, that is actually understandable. And maybe in the middle that actually we're seeing. Now the objects, many objects that you cannot see as well, but if you change the viewpoint, maybe some part of that look like this circle shape, that one is actually you cannot see that part. Okay, but maybe you change the angle, then maybe you can see like this lamppost stand, we cannot see maybe a major part of that stand we cannot see, but if you change our viewpoint somewhere in there, maybe we can see the entire body of that lamppost. Okay, so that's actually the viewpoint movements, that is actually very important, and that could be according to the perspective. Now what you cannot see, you can see in here, that is can be actually taken out by the hidden surface removal. You see now that object, this part you cannot see, right? This is, you can see now that with this box it has been actually obstructed, it has an obstruction. Okay, in front of it you have like that. So objects that are occluded, that says you're obstructed by other objects, must not be drawn. Okay, so that's actually the hidden surface removal, can be based on actually your different that viewpoint, it will be changed as well. Okay, then we do for shading. Shading is an activity related with actually two other very important parts, that the light source and the camera. Okay, so the object, how the light is reflecting coming to your eye or camera, on the basis of that actually you will see it. Okay, I'm going to stop in here. I think maybe it's more than 8:30, 9:30, so that you might also have classes and no one said anything. um, you can see here that shading is actually your last part for that geometrical pipeline, that is trace. Okay, geometry is trace. Then we'll go for actually the rasterization. So we're almost done. That is just for giving you main actually example based actually that understanding. But the basic discussion is the important discussion about the pipelining is actually your this one, that process of the pipelining. Okay, these are actually the important that activity that they do. All right. Okay. Anyone have any question? Anyone have any question? Sorry, my video is off actually. Didn't check. Okay, let's come to the video then quickly done the attendance. Do you have Ali?